Okay, so day 2 with improper integrals means we're going to get into some messier situations, especially when we have integrals that involve multiple pieces. So in this particular lesson, we're going to look at things that have sums or differences, and that can come about in multiple ways. Our first example we're going to look at has it already built into the function, and then example 2 will show you another way that that shows up. So one thing we have to keep in mind is how convergence and divergence works with addition and subtraction. So if they're the same type being added or subtracted, so convergent with convergent or divergent with divergent, then they're just going to stay in that form, right? So that sum will just be in the same form as the pieces. It's when they're different forms that we're adding and subtracting that it can get a little bizarre. So I don't think it's super surprising that divergent plus a convergent piece would still stay divergent, because we can't get an answer from that one piece, so we can't get an answer that involves that piece in a sum. This is the one we have to watch out for. So if you think back to our lesson on L'Hopital's rule, divergent minus divergent, infinity minus infinity doesn't cancel out, unfortunately. And so that's a form of indeterminate, an indeterminate answer. And so we kind of have to manipulate it in order to actually get an answer we can end at, I guess. So it means to keep going. So definitely keep your eye out for that one. Otherwise, if you have divergent divergent or divergent convergent and you're adding it, you're good. So let's jump into example 1. So in example 1, we have 1 to infinity, and so that means that we're going to have to use a limit. Okay, so we're going to say the limit as b goes to infinity of 1 to b, and I'm going to break it apart at 1x dx, and then I'm going to create that same limit as b goes to infinity of 1 to b, and then the second expression, 5 over 1 plus 5x dx. Now, if you remember our previous lesson really well, you might go, oh, this is a p-series, I can use that trick. And you can, but we're going to do it the old-fashioned way here because something else is going to happen, and you'll see where we're going with this. So the antiderivative of 1 over x is going to be ln of x absolute value from 1 to b. And then for this section here, it's still going to be natural log with a chain rule. We would have had times 5 in the derivative, and I was nice enough to give you one already, so I'll show the work to the side, but you may or may not actually need to go through those steps. Okay. So what we're going to end up with is going to look very similar to the first piece, but just with that 1 plus 5x inside the absolute value. Alright, so now we can actually do our definite integrals here. So the limit is still out front, or we still haven't found the limit yet. I like to write out this step. You may get very comfortable with these and kind of be able to do some of this in your head, but for now I'm going to keep writing out as many steps as I can, just to make sure we can see what's going on. I'm going to erase some of this stuff here so we can fit it. So we're going to have ln of 1 plus 5b minus ln of 1. Oop, JK, not 1. This one we actually had to plug something into. So it'd be the ln of 1 plus 5 times 1, which is ln 6. My bad. Alright, so let's think about our limits here. If b is growing, then the natural log of that big number is approaching infinity as well. Ln of 1 is 0. Ln of a number growing very large is a large number. And then we just have ln 6, which isn't going to be affected by our limit. And I, of course, am now realizing that there is a typo because I wanted this to be the special case, and that's not happening. Sorry guys, so this is supposed to be a minus sign way back at the beginning. So we're gonna change these all to minus signs just to make our life more interesting, you know? I always like to try that. And the reason being, I wanted you to see one of these indeterminate forms so you would kind of know what you do, because they're not super common, but they do show up. So this would, with my new edit, become the indeterminate form, because we would have infinity and then we would have minus infinity plus ln 6. Okay, and this is indeterminate form. Which means we need to do some manipulation of our expressions. So I'm going to kind of just combine this line to where they're not separated out like this, so you can see what we're really going to have here. So we're going to have the natural log of b. ln 1 is going to 0, so I'm just going to leave him out. Then I have minus ln of 1 plus 5b, and then minus negative ln 6, which will be plus ln 6. Okay, so this is the problem here where we're getting infinity minus infinity. So I'm going to use our natural log rules to condense this form. Sorry, I know there's literally not even close to this amount of room on your paper. Probably should fix that. So this is really going to be natural log of b divided by 1 plus 5b. And then we have a plus ln 6. So now you can see how this helps us, because if I'm finding this limit, this is a composition of functions, so I find the limit of what's inside first. And here we have the same power on the top and bottom, so it's going to come out to be a ratio of those coefficients. Oops, can't forget that part. And then we have this plus ln 6, and again, condense those natural logs. If you're adding them, that means they're really being multiplied. And so we're just going to get ln of 6/5. Super duper fun. All right, so that was a super complicated first example, just, you know, trying to throw you in the deep end. So let's do number 1b, and I think we'll be able to get through this one a little bit faster. So we'll have the limit as b goes to infinity of 1 to b. And then I have 1 over 2x minus 1 dx. All right, so the antiderivative of this, again, you can think of it as u substitution, and I'll put it out to the side. All right, so that's really what's going through my head. I got a lot going on there. But basically, we just have to counteract the chain rule effect of having this 2x by throwing a 1/2 out front. So we're going to have a 1/2 ln of 2x minus 1 being evaluated from 1 to b. All right. So we'll have 1/2 ln of 2b minus 1 minus 1/2 ln of 1. No, I keep doing this. I'm sorry, guys. Of 2 times 1, which is 2 minus, oh, it is ln 1. I got lucky. Oh, freaking out. Here we go. All right. And so that makes me happy, because I know ln 1 is just going to go to 0, so I can basically ignore that. And so I'm really just thinking what's happening as b grows larger and larger and larger. And I'm just taking the natural log of a number that's growing larger and larger and larger. So that's really just approaching infinity. And so this one will simply diverge. There's nothing else for me to manipulate, and that's our final answer.